Designing effective EMI shielding requires more than just picking material off of a spec sheet. In industries where performance, precision, and reliability are non-negotiable, choosing the wrong EMI shielding can lead to signal disruptions, costly redesigns, or even compliance issues. Woven wire mesh and honeycomb panels are two options that are often compared side by side, yet they serve very different purposes. Understanding these differences can help you avoid compromises in your design. Woven wire mesh offers a flexible, precision-engineered approach to shielding that excels in environments with dynamic requirements and tight spatial constraints. Honeycomb panels, on the other hand, have long been used for their rigidity and airflow properties, but may not always deliver the EMI protection or integration flexibility modern systems demand. Both woven wire mesh and honeycomb panels are widely used for EMI shielding, but the key to choosing the right one lies in understanding how each one performs in real-world applications. Honeycomb panels are often chosen for their rigid structure and ability to allow airflow, making them a common solution for enclosures that need ventilation. However, their fixed design and limited surface contact can restrict shielding performance in applications where electromagnetic interference is more complex or directional. Woven wire mesh, on the other hand, offers greater design flexibility and can be customized to fit specific geometries, signal frequencies, and grounding requirements. It conforms more easily to uneven surfaces, integrates well with gaskets and seals, and allows for tighter tolerances when sealing electronic enclosures. So the biggest difference comes down to adaptability. Honeycomb panels offer a set performance standard, but mesh can be engineered around your system's unique shielding demands. This can include minimizing leakage, optimizing grounding paths, or broadband attenuation, which makes woven wire mesh a better fit for applications where precision and variability are driving factors. And when comparing the two, it's better to consider more than just form factor. Think about installation, long-term durability, maintenance, and how easy the shielding fits into your system as a whole. In many cases, the added flexibility and performance consistency of woven wire mesh leads to more reliable shielding outcomes with fewer compromises. Electromagnetic shielding isn't always predictable, which is why shielding needs to do more than just check the basic performance boxes. Woven wire mesh stands out because it delivers shielding that adapts to the specific needs of each application, supporting both high frequency and low frequency attenuation with a balance of strength and precision. One of the biggest benefits of woven wire mesh is its customizability. Variables like mesh count, wire diameter, and weave type can be fine-tuned to target specific frequency ranges or meet strict attenuation thresholds. This level of control allows engineers to design EMI shields that work in harmony with the system rather than relying on generalized solutions. Wire mesh also fits into both rigid and flexible gasket systems, providing continuous electrical contact across seams and enclosure edges. Its high conductivity and surface area create more effective grounding paths, which is critical for preventing signal leakage and maintaining compliance with EMC standards. From aerospace to telecommunication, woven wire mesh is increasingly preferred in environments where space is limited, reliability is non-negotiable, and performance standards are high. It enables lighter, thinner, and more scalable shielding strategies, making it an ideal fit for modern designs that need to evolve with technology. And with woven wire mesh, you're not limited to one configuration or material. You gain a shielding solution that can be engineered around your challenges without sacrificing long-term durability or electromagnetic performance. Honeycomb panels have long been used in EMI shielding due to their lightweight structure and ability to allow airflow, making them a common choice in applications like ventilation systems or RF enclosures. However, in many real-world scenarios, their performance can fall short, especially when flexibility, precision, and integration are key. One of the main limitations of honeycomb panels are their rigidity. While they perform well in static, open-frame applications, they aren't easily shaped, resized, or integrated into tight or irregular enclosures. This makes them less ideal for modern devices where space constraints and modularity are part of the design. Another challenge is their susceptibility to gaps and signal leakage. Honeycomb structure rely on their physical structure alone for shielding, which can allow EMI to pass through seams, mounting points, or poorly bonded surfaces. This makes achieving full shielding coverage more difficult, especially in high-frequency environments where even small gaps can compromise their protection. Honeycomb panels also offer limited customization. While different cell sizes and materials exist, the degree of control over specific EMI attenuation ranges is far lower than with the woven wire mesh. And because they're typically fixed in shape and size, adapting them to evolving designs often means starting over with new tooling or configurations. So, in short, honeycomb panels serve their purpose in specific niche environments. But for applications that require adaptable shielding, tight tolerances, and consistent long-term performance, they can create more limitations than solutions. Thanks so much for watching. If you have any questions, click our Talk to Us button to get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert.
We also have a YouTube channel.
And don't forget to click that subscribe button and ring that bell to keep up with all things WS Tyler. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.